All right. Well, then good afternoon, everyone. Today is the day I ask you all a very important question. It's a question I end up asking every class at some point during the year, sometimes multiple times in the year. It's always a good reminder, good thing to think about every once in a while. That is this: why are you here? And I'm not saying like broad philosophical, why are we all here on this planet? That's not what I'm getting at. I mean specifically, why are you here enrolled in this school, taking this class? What is the purpose of all this? Because consider, for example, the dichotomy of outcomes Alfred brings up. You do not want to become a victim of life. Wouldn't it be much better to, as Batman did, make the effort and master the chaos sweeping around us? There's an awful lot of chaos sweeping around this year. Okay? Part of your purpose of coming to this school in the first place is to better yourselves, to educate yourself, to gain that knowledge and those skills that will make life easier in the future. But that means right now, it's going to be hard. Okay? He didn't say to instantly master the chaos. He said make the effort. It requires work. But in the end, you will come to be able to have more control over, not exactly death, but your life, really. And if that's something you want, to be able to make those choices in the future about where you go to college, what job you get, you have to make the decisions now. Today, tomorrow, every day of every week. What are you going to do with your time? Especially those of you sitting at home, it's very tempting. You're there staring at the computer. What's so different? Listening to the teacher yammer on versus, I'll just go play some video games, chat with my friends. It's very tempting, very easy to do. But is that your purpose right now? Does that forward your purpose? Does that get you to where you want to be? Why are you here? And why then do you do anything at any given moment? Challenge you to be more purposeful with your actions. Okay? Whether that means it's necessary to turn in your late work, or if you're already on top of things, how to do even better. Always room for growth. All right, that's my philosophical rambling for the day. Now, onwards to mathematics. Our purpose today is to look at the fourth law of logical reasoning that we've seen so far. We started with Modus Ponens, or you now know there's an alternative name for it. You read about it this weekend, law of detachment, which is a much more descriptive form. It detaches the conclusion off of that conditional. Very handy. I prefer the Latin term. It's just more fun to say Modus Ponens. But you can use law of detachment if you prefer that. All right, so we got that one. Then we had modus tollens, which was kind of like a backwards version of law of detachment. So they kind of went together. Then we had law of syllogism, very useful for consolidating lots of conditional statements. And now the fourth one, law of contrapositive, will be useful for determining alternative ways of phrasing things while still maintaining their truth value. Now, you got to be careful. You don't want to just change up a statement and accidentally change its inherent meaning, because it may no longer be true. Or if it was false, it suddenly becomes true, and then it's not what you were talking about. So in order to understand law of contrapositive, we must first look at a conditional statement and the three ways we could change said conditional statement. A conditional puts specific pieces of information in a specific order And if you disturb any of that, you've changed things. So without introducing some new information, what are the ways you could change it? Which ones are still valid? We have option 1, the converse of the conditional statement. And if you do not have these 3 terms in your notes already, please add them now. But the converse of a conditional statement reverses the 2 parts of the statement. We change the order of it. Right? If you started with if A, then B, we swap it around and say if B, then A. Okay? It reverses the cause-effect order. Converse of a statement reverses the order. Similarly, but quite differently, the inverse negates the 2 parts of the statement. Instead of if A, then B, the inverse would say if not A, then not B. We've negated both sides of it. And I have searched far and wide for a better mnemonic to help you remember which one is which. I have yet to find anything. You're just going to have to work hard and commit to hard memory. It's unfortunate. I wish we had a better understanding, but that's the way it is with vocabulary sometimes. Converse reverses, inverse negates. I know they sound similar, but they're 2 very different processes. And then finally, perhaps actually the easiest to remember, because it's the longest word and therefore the most complicated process, the contrapositive does both. It reverses the order and negates them. So instead of if A, then B, we have if not B, then not A. All right? Now, the book presents an example here, and it's a good example, but this example is based on a specific geometric property that, since we're starting with logic, we haven't yet investigated ourselves. So I'm going to assume that this property is not yet intuitive to you. So instead, I'm going to use a different example that I think we do find more intuitive. And that is this phrase: if it is raining, then the ground is wet. And if you were outside at any point last period, you may have experienced this yourself. Or perhaps sometime this weekend, right? We've all been outside, we've seen rain, we know what it does to the ground. Definitely the case. Every time it rains, the ground ends up wet, right? Except maybe a little patch underneath your car. Right? We can come up with like minor exceptions. But in general, if it is raining, the ground is wet. We can agree that that is always true. But if you change things around, what happens? Here is the converse of that statement. If the ground is wet, then it is raining. Is that always true? No. We can think of plenty of counterexamples that say, well, I've seen wet ground before. In fact, if I go outside right now, the ground is currently wet, but it is not currently at 13:55 today. How'd my watch end up in 24-hour time? I don't know. 1:55 today. It is not currently raining, but the ground is wet. Therefore, that's false, because it was raining earlier, and so the ground got wet and is still wet. Right? This statement does not take that temporal difference into account, so that statement ends up false. Right? Or perhaps you set out the sprinkler. It's summertime, you water the lawn, you run through it, set up the slip and slide, ground ends up all kinds of wet, but it was not raining. Right? So this statement we know in our experience to be false. It is not always the case. There's other ways to make the ground wet besides just rain. And that makes this false. The other thing we could do is we could negate both halves of our original statement, create the inverse, If it is not raining, then the ground is not wet. And for similar counterexamples, we can conclude that also is false. Every time it's not raining, the ground is definitely not wet. It will never be wet, no matter what. Again, right now, it's not raining. That part's true, but is the ground not wet? Nope, we've got wet ground outside right now. So that whole thing then is false. That conditional does not always hold. However, you put both of them together, and it turns out two wrongs can make a right sometimes. If the ground is, if the ground is not wet, then it is not raining. How about that? If the ground is not wet, every instance of perfectly dry ground, if that is the case, is it always not raining in those circumstances? You'd have to say yes. Right? I can't think of any time I've found dry ground outside and it was raining. Right? Every time it's not wet, it's definitely not raining at the same time. Because we've reversed it and negated it. One process undoes the other, if you want to think of it that way. You get a true statement. The contrapositive will still be true if you start with a true conditional. The other ones, however, not the case. They could end up true depending on the circumstances. Right? In this case, they're not, but you could come up with a scenario where reversing it also works, or the inverse is true. It's possible, but not always. It doesn't automatically follow from rules of logic. You'd have to know more about that specific circumstance. Okay? So then here is the law of contrapositive written out. It just says that if a conditional statement is true, then its contrapositive is also true. That's the whole law. You are free to swap back and forth between them. All right? Here's a conditional, therefore, contrapositive. And one of these versions might be more useful than the other. Right? Certainly in speech patterns, sometimes maybe it makes more sense to somebody to put it in negative terms. Or perhaps you started with it in negative terms and you want to reverse it, put it in positive, phrase it positively. Right? If you try to go up to somebody and say, hey, if the ground is not wet, then it is not raining. Be like, wait, hold on, too many negatives. What is he saying again? Put in the contrapositive that. I'm like, oh, I get it now. Yeah, you're right. So sometimes for ease of communication, it helps to swap. And sometimes for ease of determining truth, even symbolically, this can make things useful. For example, pretend you don't like modus tollens. You're like, oh, that was always a tricky one. I never understood. You get like the negative, but it's got to be the second half, and it always confused me. Well, look at this now. If I started with if P, then Q, modus tollens would have me state not Q. I would need that to then go to say, therefore, not P by modus tollens, right? But if instead you use the law of contrapositive first, you change if P then Q to if not Q then not P, Now I'm restating the hypothesis. Hey, I've got a conditional. I'm stating the first part. Now I can conclude. We'll grab the whole thing there. Call that, our third line, as it were. 1, 2, 3. But now we're using modus ponens. It's much more straightforward. So if modus ponens made sense to you, but modus tollens didn't, law of contrapositive lets you switch from using one versus the other. And then in this way, we could see modus tollens is almost more of a shortcut. Right? It's one step instead of 2 steps contrapositive than modus ponens. Okay? So there's definitely a relationship there. The exercises today, I believe the last one, 27, will actually ask you to explain the relationship between these 3. So there you go. I hope you were listening. You'll have to restate what I just described there. All right. Any questions then on law of contrapositive? How to use it? No? Then, the final thing this section does for us, very kindly, since we've gone through all 4 forms, they have summarized them there for you. So reference that as you go along, because now, in these exercises, you're going to have to identify from 4 different structures, or maybe none at all, right? Which category any of these purely symbolic arguments fall into. And that's going to be the majority of today. You're only doing the odds, but even so, that's 1 through 12, and then 13 through 24 is all the same thing. Right, so it's pure symbolic manipulation today until you get to 25. Turn this Venn diagram into a conditional statement. Many ways of interpreting that, whether you want to start based out of the triangles or based on a polygon. If a polygon, then what? Right? Or maybe outside of it. If you're not a polygon, then, right? Lots of ways to use that. And then, as I mentioned, 27, show how to use modus ponens and law of contrapositive to make the same conclusion as modus tollens. You can explain that in words, if you'd like. Or you could write up 2 symbolic arguments, show that they're equivalent. Right? So they both start with the same thing, and they both end with the same conclusion. So see, they get to the same place. So up to you how you want to show that, accept any method there. That'll be it for today's classwork. Before you dive in, one comment on this week's homework. Those are exercises taken from the book you've been reading these last 2 weekends. So that is a college level text. It's a little bit tougher, a little bit denser, as you've noticed. The exercises, though, are still based on the same logic that we're doing today. So in essence, they're not really any more difficult, but it might be a little trickier just based on the language used. Some of the examples and the way they phrase things there might be a little bit different. They have also included the and or operations. We haven't talked about that. We'll get there this week. But because of that, I'm trying to give you more time to work in class. Tomorrow, we're just going to review the answers to this. We'll take a short quizzes, and then you'll have the rest of the time Tuesday to work on this week's homework. So please look at it ahead of time. Don't wait and save it until Thursday night to start that. Okay, I'm giving you time this week to work on it. All right? With that then, I'll leave you to it. We got, 25 minutes to work. Make them count.